Hey guys, what's up? Welcome back to another video. Today I got a pretty interesting one. I'm working on a 2014 Chrysler Town and Country, and customer complaint is that when he got off of work yesterday, he got in the vehicle, went to turn it on, and none of the interior accessories are working. So let me go ahead and show you. Got the key right here. I'm going to stick it into the ignition. I'm going to turn the key on, and the first thing he noticed, and what you'll probably notice, is that the wiper blades are staying on, and it doesn't matter what position you put the switch in, the wiper blades just stay running. The other thing that you'll notice is that the radio doesn't come on. The screen, nothing is registering. Nothing here works. The AC is not working. The blower's not working. Apart from the Christmas tree that's on in the cluster, which we'll get back to in a second. The windows, none of the windows work. So I'm moving the switches here. None of the windows are working. Looks like pretty much everything that's on the interior is not working. None of the controls work on the steering wheel. By the way, the vehicle still starts and runs. So as you can see, I just started up the vehicle and he was able to drive it here. No issues with actually driving the vehicle. It's just that nothing inside works. And the other thing he noticed was this red dot. He said he had never seen it there before, but you can also see that every other light is on. So I mean, we've got the traction control light, ABS, tire pressure, check engine light, brake light. We have the battery light and the lightning bolt here. But really what stuck out to me, as you can see in this little display right here, is that it says no bus. So that kind of led me straight to a CAN communication issue. Anyways, I just kind of want to bring you guys on the journey along to trying to figure out what's wrong with this truck. I don't know what's wrong with it yet. I haven't ever run into this problem before, so this should be fun. I hope you guys stay tuned for the video. Hopefully we'll find something really interesting. Before I move into plugging in the scan tool, I really want to disable these wiper blades because not only are they annoying, but they're really going to drain the battery because they stay on even when the key is just on. So let's just go ahead and pull the fuse. I've already located it. It's this 30 amp fuse right here. I'm gonna go ahead and pull it out, and that should disable the wiper blades there. As we can see, they're no longer working. All right, so now that we're not worried about the wiper blades draining the battery, we're gonna go ahead and move to the scan tool. All right, so the first thing I want to do is I want to run an auto scan on this thing. So let's go to Diagnosis here, and we're going to run an auto scan. And what that's going to do is it's going to scan all of the modules that are on the vehicle and give us a list of the trouble codes that are popping up. So as you can see, it just scanned the PCM. There's a fault in there. ABS, there's a fault. The central gateway, there's 6 faults right here. Wireless control, there's a fault. Just let this thing finish scanning. If it tries to scan the module and it doesn't do either one of two things, which is either pull a fault code or do a pass no fault, that generally means that the module that it was trying to scan either doesn't exist or it's not communicating. So I'm just kind of throwing that out there. So let's go first to the powertrain control module, and let's see what fault codes we read in there. Battery system voltage low. Yeah, I'm gonna have to put a battery charger on this thing. As you can see, the system voltage is right up there, so 11.33 volts. All right, so let's move on to the ABS module. Okay, read codes. We have a left front wheel speed sensor circuit code, out of range. That may or may not have anything to do with that. This was probably there before any of this happened. I'll have to ask the customer if he had an ABS light on or not. The other code you can see here, system voltage low. That was from the battery being low. So let's go back out here. Central gateway, which I think is another name for the TIPA module on this vehicle, which is the fuse box. The fuse box is a module. All right, now here we have a lot of codes. So first one we're looking at, wiper park switch input circuit low. Second one, wiper park switch input circuit high. We have a U code, some U codes or communication codes. CAN interior bus. So that's I think a really important one there. Lost communication with cluster. Lost communication with HVAC control module. Lost communication with door module front right. Lost communication with power sliding module, power sliding door module on the left, and the same thing for the right. Okay, so what I'm noticing is that all of these codes involve the interior, which means we know we have a problem in the interior bus CAN system, and then we have these codes here. So let's go back and see what we have as far as fault codes in the wireless control. Low tire pressure, so that may or may not have anything to do with what we're dealing with here, but really what I want to focus on is this central gateway and all of these fault codes that are popping up for the interior CAN system. Okay, so this is what we're going to focus on. What I want to do next is I'm going to pull up a wiring diagram of the CAN system to get a better idea of how the system works on this vehicle. So let's go to that next. Alright guys, so I'm here at the workstation in the back of the shop. Before I get into the wiring diagram, I just wanted to go ahead and pull up some information on the description of the operation of the system. Essentially what it's saying here is that there's actually 3 separate CAN bus systems used on this vehicle. So they're designated as CAN interior high speed, which is IHS, CAN C, and then also the LIN, which is local interface network. Let me do this. I'm gonna see if I can draw this up to make this a little bit simpler before we get into the diagram. All right guys, so I'm here in my office. I wanted to draw this up on the marker board over here just to make it simpler. I was a little bit worried that if we went straight into the wiring diagram, it may get a little bit confusing. So what I went ahead and did was drew up a watered down version of the CAN bus network system on this vehicle. So let's get straight into it. All right, so on the description that Chrysler gives us, they designate that there are 3 different CAN systems on this vehicle. CAN C, CAN IHS, which stands for interior high speed, is what IHS stands for. And then there's CAN LIN, which stands for local interface network. All right, so now that we know the 3 different CAN systems that are on this vehicle, let's go over and see how they're laid out. So I'm gonna kind of stand back, let you get an overview. Again, this is a really watered down version of it, but I just wanted to make it simple. All right, so as you can see at the heart of this, what we have is the TIPA module, TIPM, which stands for Totally Integrated Power Module. But this is also known as a central gateway. And when we look at it on the scan tool, that's what it's called, central gateway. Again, what we have here is CAN C. And then of course, CAN systems are gonna have 2 lines, which is a high and a low, which is designated as plus and minus. So if you look over here, you see C plus, C minus, C plus, C minus, and then over here, IHS plus and minus. So let's concentrate on the CAN C. So what we're gonna have that's interesting on this system is that we have a separate leg of the circuit that goes straight to the DLC connector. this is where we connect our scan tool, and that's going to be pins 6 and 14. We'll get to that later, but I just think it's interesting that on this system we don't have a direct connection between the DLC connector and the rest of the CAN system. We have this kind of bridge between this leg of the circuit and the DLC connector. So I guess what I'm getting at is I don't know if when we go after this with the lab scope, if we're going to see all of the activity that's happening here, because the only activity I think we're going to see from here is whenever the scan tool is trying to communicate, and it's going to be sending signals here, but we'll get to that later. But just understand that on a lot of systems, or most systems that you'll run into, the DLC connector is going to be directly tied to the CAN system. But in this case it's not. We have the TIPM module that is the central gateway. So we understand that we have a separate leg of the circuit for the DLC connector on the CAN C. So this is still the same. These two are still the same. They're CAN C is what we're concentrating on right now. So that includes the PCM, which is the powertrain control module, things like the ABS module, and things like the tire pressure monitoring system module. Those things are going to be communicating together. Now they're not all in the same module. I just drew it this way to make it easier. These all have wires going to each individual module where they all communicate on the same network. So on the CAN C, what we're mainly dealing with is chassis and powertrain modules. By the way, the transmission control module on this one is integrated into the PCM, so there is no separate transmission control module. But anyway, that's what we're dealing with as far as CAN C goes. Now the CAN system that I believe we're having a problem with is the IHS, which stands, again, it stands for Interior High Speed. Again, CAN IHS. What this CAN system deals with, again, we have a high and a low, are modules that, and this is very watered down because there's a lot of different modules that we're dealing with on the interior system. But things like door modules, and this is going to include the front driver's side door. Also, it's going to include the sliding rear doors. It's going to include the seat memory module, the radio, and it's also going to include the HVAC system. And again, like I said, there's also a ton of other modules, but we don't need to get that into it yet. But just know that we're dealing with mainly the interior of the vehicle. That's why it's called Interior High Speed. So again, in overview, the CAN C system is mainly dealing with the powertrain and chassis, and the IHS is dealing with pretty much everything inside the vehicle or accessories. Now moving over to the LIN, which is the local interface network. This is actually not a high-speed data bus line. It doesn't use a high and a low, where, like I said, most CAN systems that are working on a high-speed network, they use a high and a low. This is kind of just a low-speed local communication network, and it's not module to module. It's basically mainly for switches. So things like the door lock switch will connect to the door module. Well, this really should be drawn up a little bit differently for the sake of being correct here. Let's draw this up like this. The door module. This marker's giving me some problems here. Okay, so the door lock switch or the window switch is going to have a single LIN, local interface network line, that is what's going to command the doors to either unlock or the windows to go up and down. So the LIN is just module specific, mostly switches that are telling a certain module what to do. That's what the LIN is. So that's a totally separate thing. We're not really dealing with that. Just wanted to throw that in there. So where we have a problem is with the IHS, because when I hook up the scan tool, we can communicate just fine with all of these modules. Everything on the CAN C system seems to be working, but we don't have any communication with anything on the IHS here. So that leaves us with a lot of possible causes here as to why the IHS is not communicating properly. For instance, we can have a problem where one of these modules is bad, causing miscommunication between all of the modules, or we could have a wiring problem. We could have a short somewhere. We could have a open in the wire. I mean, the possibilities are pretty vast. We could also have a problem with the TIPA module. Maybe everything here is working, but the TIPA module is not communicating with the rest of the circuit. So at this point, the list of possibilities is pretty big. So my next question to myself would be, how do I want to attack this? Okay, so I think what I'm going to do, just because this is standard procedure that I do with most CAN related problems, is I put my lab scope on pins 6 and 14. All right, so we're back over at the vehicle. Wanted to show you real quick, I got my lab scope hooked up, and what I'm using is this breakout box for the DLC connector. Let me show you here. Basically what we do is we plug this box into the DLC connector right here, and we can plug in our scan tool on this end of it. It allows us to tap into the DLC connector pins while we have the scan tool hooked up. As you can see, I'm tapped into pin 6 and pin 14. I went ahead and pulled up some information. Let me show you. If you look here, you'll see CAN C, CAN low and CAN high. With the key on, you'll be seeing between 2.4 and 2.5 volts on both lines. So what we're seeing is correct. What we want to see is activity here. And if you've watched my previous video on CAN bus systems, you'll know that what I like to see on the signal is that they mirror each other. When one goes up, the other one goes down. And so that's what we want to see here. What I find interesting is that with the key on, I really don't see much of any activity happening here. Let me go ahead and start the vehicle and see if that changes. All right, so now the vehicle is running. I'll try to get a little more steady with my camera here. All right, so now that the vehicle is running, I was hoping to see a little bit more activity. I'm gonna set a trigger here. See if we can capture any activity. We pretty much just have a flat line here. What I'm guessing is that we're not going to see all the activity between module to module on this leg of the circuit. This leg of the circuit is probably strictly for scan tool communication. That's just my guess. I mean, I'm not an engineer. I can't be 100% certain, but what I can tell you is that I have the scan tool hooked up, and I'm just going to try to go into a module here. Go to Powertrain, and I'm just going to go to, let's say, the engine control module here. And when we start communicating, we start seeing activity. So as you can see, we got plenty of activity there. Let me go back over here. Let's just go to like live data. Okay, live data should be continuous, so we should see a whole lot of information being shared here. So these are all the data PIDs. I don't really care what they say. What I want to see over here is that we have activity. And I get the feeling that I'm correct in my statement in saying that this leg of the circuit is strictly for scan tool communication. What we're looking at here is activity between the TIPA module and the scan tool. But I do see a signal that I like, and this is what we're looking for. What we're looking for is that the signals mirror each other. So when this one goes high, this one goes low. Okay, so just to reiterate, I'm going back to my simple graph here. Where we were with the lab scope was we were hooked up to the DLC connector on pin 6 and 14. And what we found is that we're not really seeing any of the communication that's going on between modules. I think what we're getting is a conditioned signal. This TIPA module has a microprocessor in it, and it's processing the signal that's coming in, and it's processing the signal that's coming out. So what we're seeing on this leg of the circuit really isn't going to help us. Let's just put an X over this. It's not helping us at all. Again, we know that we have a problem with the IHS. We don't have a problem really with the C CAN bus system, so we're not even going to bother messing with it. I think my next step is I'm going straight to the TIPA module, and I'm going to find these two pins, and I want to hook up my lab scope here. All right guys, so here I am at the TIPA module. As you can see, this is a C7 connector, and I have my 2 channels back probe on the IHS high and low CAN lines. The wire colors are white and orange and white and gray. That's pins 26 and 27. I'm back probed here. I'm going to go ahead and put this back together, and we're going to see what we have on the lab scope. All right, so looking at the lab scope, the key is off right now. And to be honest with you, I'm not really sure what we should be seeing. According to this document that I pulled up on All Data for this vehicle, it says that the interior bus circuit, with the key off, the bus should be asleep. Key on, the bus should be active. And then it gives us this short to ground on high and low, blah blah blah. It doesn't really tell us what voltage we should be seeing. Like on the CAN C circuit, you know, it told us that we should be seeing like 2.5 volts, and that's what we were seeing on there. But in this case, for the interior, they're just not giving us a whole lot of information. So let me go ahead and turn the key on, and then we're gonna see what shows up on the lab scope. So I got the key in the ignition, key is on. Let's go back out to the lab scope. And what I'm seeing is that we're looking at 0.30 volts and 0.03. So I'm not sure if that's normal or not, to be honest with you. I don't really know. I am in the graphing mode, so let me go into the lab scope. We need to go a little bit faster because I was only on a 1 second time base. I want to get a closer image of the pattern or the waveform that we got there. Maybe we can, well, we're gonna have to go to a smaller scale, so let's go to a 2 volt scale instead of a 5 volt, so we can get a closer image of that. Let's set a trigger here to make it easier. We'll set it for channel 1. Yeah, let's readjust that trigger. Let me bring the trigger down. That seems to be about right. So let's go into 10 millisecond time base. That way we can see it a little closer. Maybe 5 milliseconds. Let's see. Okay, so we're seeing some activity, but I can tell you right now what I don't like is that, for one, these two are not mirroring each other. When this voltage is going high, this voltage is also going high, so they seem to be pretty much the same. The other thing that I noticed is that I really had to zoom into like a 2 volt scale to get to this image, so it seems like the voltage is pretty low. So those are two things I don't like about this signal. The next test that I want to do is I want to start disconnecting the modules or the nodes on this circuit until I see a signal that I like. Alright guys, so I'm going to spare you the boredom of me having to remove the door panels, having to remove the radio, having to remove the HVAC control module, and I'm just going to get straight to the point. Basically, I needed to access each of these modules, disconnect them independently, and check to see if the graph on the meter changed. All right, so as a quick example, this is the door control module on the driver's side. If you look here, this connector has the 2 CAN wires, this twisted pair. It's a white and orange and a white and gray wire. When we disconnect this, if this module is bad or causing a problem with interference, then we'll see a change in the graph. So let's go ahead and take a look at the graph. As you can see, there's a signal that we don't like. I'm gonna go ahead and unplug it. Module is disconnected and we see no change. So I disconnected the module and we don't see a change in the graph. So we know that this module most likely is not the cause. Next, we need to go through and disconnect modules one at a time to start trying to identify where the problem is. And just to give you an idea of what I had to go through to find the problem, I've already found the problem. I just kind of want to show you what I had to go through. First of all, I did have to remove both door panels on the other side. You'll see another little box right there. That is the door control module for the passenger side. I had to remove the door panel to access that module so that I could disconnect it. When I disconnected it, I didn't see a change in the graph. I also had to remove the radio head unit, disconnect this. I had to remove the HVAC control module, disconnect this, and I didn't see a change in the graph when I disconnected them. The other thing is the rear doors. These sliding doors on the rear also had modules in them. The nice thing is that there's an easy access to the connector down here. If you look underneath, if you follow that harness, you see that connector right there. I was able to disconnect that on each side and verify that there was no problem with the door modules. Those are good. Let me show you where the problem lies. Okay, so on this particular vehicle, we have DVD player and this monitor that comes down from the ceiling here. Let me get it on the other side. Let me show you. You just push this button here and this monitor comes down. Really neat. But let me show you where the problem lies. So this bulk connector right here contains the CAN wires for the IHS that go to the module for the DVD here. And let me show you what happens when I disconnect it. All right, so looking back at the lab scope, you'll see the signal that we don't like right there. Let's come over here and let's disconnect this harness. Sorry, it's kind of hard to do this with one hand. I'm going to disconnect this. There we go. And then we're going to take a look at the lab scope. And the first thing that you'll notice is that we're actually off the chart here because we're on a 2-volt scale. So I'm going to switch that over to a 5-volt scale on both channels. All right, and now let me reposition myself here. Let me try to do something about this glare. Hang on, let me turn off the light on the camera. Okay, much easier to see with the light off. Okay, now that you see that signal, that is a signal that we want to see. When one channel is going up, the other channel is going down. That is a good signal. Again, I disconnected the connector for the DVD player, and now we have a good signal. So let's go ahead and let's cycle the key here, and I want to show you that everything is working. So I'm going to go ahead and start the vehicle up. All right, so probably the first thing that you'll notice is that we don't have the no bus display on the instrument cluster here. The little red dot is gone. We still have an ABS light, but there's a wheel speed sensor problem with this. The radio is working, the AC is working. The wiper blades, I was able to put the fuse back in it. They're no longer staying on. The windows are rolling up and down now, so let me go ahead and show you that. Roll the windows down and up. All the windows are working, even the back ones. So looks like that's a fix as far as locating where the problem is. All right guys, so as you can see, we were able to get everything inside the vehicle working. As soon as we disconnected the module in the roof, everything started working inside. The only problem I have is that the customer showed up a little bit sooner than expected, but he was pretty ecstatic to see that everything inside the vehicle is working, and he actually really didn't want to go any further with having me remove the assembly of the monitors and the HVAC control unit that's on the ceiling. There was going to be some extra labor involved in that because he had already accumulated quite a bit of labor charges for me having to remove a lot of the door panels and stuff like that when it came to the diagnosis part of this. So he was actually pretty happy with just leaving it unplugged and have everything operating inside. Now I know there's going to be some questions here, and I wish I could give you an answer. I have a couple questions myself that I wish I could answer. Number one is whether or not we had a problem with either the DVD control module or if we had a problem with the HVAC, the rear HVAC unit, because there is a HVAC AC controls on that ceiling too. So either we had a problem with that or we had a problem with the DVD module. Either way, the customer just didn't want to do it. So I can't make him do it. And for me to remove everything and not get paid for it just so I can look at it, I don't have time for that. But I still think that there's a lot of value in this video. You can use this method to diagnose pretty much any CAN communication errors that you might run across. All right, so a couple things that I just want to address before the video is over. One of the things is that, yes, it was necessary for me to have to remove the door panels and remove the radio and the HVAC controls because this vehicle is not equipped with a splice. Some vehicles, if you're lucky, they have a splice where all of the modules meet at one certain location and you can actually disconnect them from one central location, which is really easy to do. It's way easier than having to remove door panels to access the modules so that you can disconnect them. Unfortunately, this truck does not have any splices for the CAN bus system, so we just had to do it the hard way. Second thing I wanted to address is that, yes, there are some other checks we can do. There's also an Ohm Check. We can check the resistance of the CAN bus system, which I did. I filmed it. I wasn't sure I was going to include it in this video, but I'm going to show it to you anyway. If you look down here, they're telling you that the can interior should have a total resistance of about 60 ohms. So let's go ahead and check that. First thing we need to do is disconnect the battery, because this needs to be done with the battery disconnected. So it's disconnected there, and I've already set up my leads. I'm on the 2 wires on that on the connector here, pins 26 and 27, and we're going to do a total resistance check on the meter here. Let's go to ohms, and according to Chrysler, we should be seeing about 60 ohms of resistance. And as you can see right here, we've got 59, just right about 60. So what that tells us is that the 2 terminating resistors in the IHS circuit are good. There are 2 120 ohm resistors. One of them is located in the TIPA module. The other one's located in the instrument cluster. That's according to Chrysler. So if you have 220 ohm resistors that are set up in a parallel circuit, they'll divide and you'll get 60 ohms. So as far as there being a problem with the terminating resistor in either the TIPA module or the instrument cluster, we're able to easily rule that out. I just wanted to do that check before I move into having to disconnect each module on this vehicle, because the problem is that this vehicle does not have a splice where we can simply just remove the splice and disconnect the modules one at a time at one simple location. We actually have to remove panels all over the vehicle to access the modules. So that's going to be next. So this ought to be fun. All right, so the third thing I wanted to address was some of you may have noticed that on the lab scope, the signal was a little bit kind of noisy. It wasn't really a pretty square wave like you would normally see. And the reason behind that is because I had the filter turned on the lab scope. So I didn't realize this till after I shot this video, but I really don't think it takes anything away from the useful information or the value that is in this video. Just because we're not seeing a pretty square wave doesn't mean that we can't see the images that we're looking for. Again, we're looking for the 2 images to mirror each other. So we saw what we needed to see. We were able to diagnose the vehicle quickly, and we were able to get it done. The customer's happy, and we're able to move on to the next vehicle. Anyways, guys, thank you for watching the video. If you have any questions, you can always comment down below. If you like the channel, if you enjoy it, please subscribe to the channel. If you like the video, please give it a thumbs up, and thank you for watching. I'll see you in the next one.